presented with a histogram which shows us the number of hours overtime claimed by 40 staff in a month. The important thing to remember about a histogram is that the area is proportional to the frequency. The problem with the question is we're not told any of the individual frequencies. We don't know how many staff claimed between 0 and 2 hours of overtime. But what we do know is that there were 40 staff in total. So if I focus more not on the individual bars but on the total area, I should be able to make progress with the question. If we look at this first bar, it's 4 squares wide and 40 squares high. That means it's got an area of 160 squares. And using the same method, we can find the areas for the other bars. In total then, I've got 400 squares, and those 400 squares must be proportional to the 40 staff that they represent, i.e. each square represents 0.1 of a staff. If we go and look at part A, it says calculate the number of staff who have claimed less than 10 hours of overtime, i.e. the staff represented by these first 3 bars. In total, those bars are 340 squares. 340 times 0.1 of a staff tells me that they represent 34 members of staff. And that's the answer to part A. In part B, we're asked to estimate the median. Now, we have grouped data 0 to 2, 2 to 5, 5 to 10, and we have 40 members of staff. So therefore my median is n over 2, or 40 over 2. So we want the 20th member of staff and the number of overtime hours that they claimed. Well, there are several ways we can do this. One, we need to remember that the median is the middle of the data. So if I look at what each of the bars now represent, that first bar represents 16 staff, 12 staff, and so on. If I want the 20th staff member in order, I know I've got 16 covered by this first bar, so I need 4 more, or 4 staff into this bar. There are 12 staff in total in that bar, so 4 out of 12, that's a third of the way into this bar. A third of the way between 2 and 5 is actually 3, so my median is at 3. That's a little bit of an unusual way to do it. What we would normally do is look at where the histogram has come from. Histogram comes from a frequency table, and now we've got all the frequency data, we can actually build our own frequency table. We want the 20th staff member, so if I add in the cumulative frequencies, we can see that that 20th member of staff is within the 2 to 5 category, and from there I would use linear interpolation. So my class on the frequency side goes from 16 to 28, and I want the 20th position. On the category side, we know we go from 2 to 5, and that will be my median. If we did the calculations for this, then we know we need to know how far into the category size we are over the full width or category width of or frequency of that category, and times it by the width of the frequency, which of the category, which is 2 to 5, so 5 minus 2, and add that on to 2. And that tells me, again, the median is 3. Part C, question asks me to calculate the mean number of hours. So with my newfound frequency table, if I replace cumulative frequency now with the midpoints, I can times the midpoint by the staff number, which is your frequency. We can do this by hand or by using a graphical calculator. We know the formula for the mean is it's the sum of the frequency times, in this case, the midpoints divided by the sum of the frequency. And my graphical calculator tells me that's 213 divided by 40. We knew because there's 40 members of staff, so 5.33. In part D, it says state giving a reason whether the manager should use the median or the mean to compare the overtime claimed by staff. Now, if we had a symmetrical distribution, it wouldn't matter. The mean is approximately the same as the median in such a distribution, so there wouldn't be an issue. However, in our distribution, we have positive skewness. That means most of the data is at the low end, means I've got some high outliers. For negative skewness, which we don't have, I would have low outliers. If you do have skewed data, it means you have some form of extreme values or outliers, and that is going to have a big effect on the mean. It won't have a big effect on the median. So in our case, with positive skewness, we've got some high outliers, and they're going to drag the mean upwards. And we saw from part B, we know the median is 3, and from part C, we know the mean is 5.33. That mean has been dragged up by those high outliers, and as such, the data is skewed. In such a scenario, it's always best to use the median, so that gets you 1 mark, but we also need to